Hello everyone, my name is Jean Lawrence and I'll be discussing my study on determining whether a supply chain logistics simulation had any impact on improving the systems thinking skills of students in a logistics course. Here is an overview of my study. First, I'll discuss the aim of the study, then describe the problem. I'll then walk through the methodology I used, discuss the results, and end with some concluding remarks. So the aim of the study was to determine whether a cloud-based supply chain logistics simulation tool helps students improve their systems thinking skills. The null hypothesis was that there is no significant difference between students' systems thinking skills before and after administering the simulation. The alternative hypothesis that I was trying to prove is that the simulation would have a significant impact in improving systems thinking skills. So here's the problem. Systems thinking skills are not typically emphasized in supply chain or logistics programs, but need to be given more emphasis. So if the simulation is found to impact the systems thinking skills of the students, then it could be used to help students develop both their supply chain skills and concepts and systems thinking skills concurrently. Now, as we've learned in this course, supply chains are dynamic by nature. They have continuous flows of inventory, information, and cash. So it's important to visualize the supply chain in this manner. And so because of the nature of supply chains, having a grasp of system dynamics is important. And one aspect of system dynamics is systems thinking. The other point is that high-performance supply chains have been associated with well-developed systems thinking skills. So it is beneficial to help students develop these skills before they go out into the workforce. Now, students often have difficulty visualizing the supply chain as a system. It's typically easier to focus on one node or one aspect of the supply chain and solve the problem, so probably a warehouse issue or transportation problem, rather than thinking about making multiple trade-offs across the supply chain simultaneously. So if students can develop the perspective of the system as a holistic entity, their system skills should be improved and they will be more effective supply chain and logistics managers in the future. So this is the methodology I used. The population for the study was an undergraduate class of students in a logistics program, and the learning styles of the students are primarily kinesthetic and visual, which was very important in selecting the simulation. Prior to the simulation, I reviewed a number of serious games and other simulations, and I made this final selection based on criteria that I had set. Because the simulation was being administered in an international logistics course, it needed to have an international perspective. I also needed it to emphasize the dynamics of the system and holism of the system, as well as constraints and trade-offs. It was also important for the students to have an opportunity to design or redesign the supply chain rather than taking the structure as given. The simulation needed to have an attractive interface, be challenging, engaging, web-based, and focus on distribution rather than manufacturing. So this is what the interface looked like. Students found it very appealing. They could place their facilities anywhere they chose. They could create the routes and experiment with different routes. And when they ran the simulation, they could see the trucks and ships moving through, which was quite nice. So the students played in teams of 3. They had 5 challenges, and in all of these challenges, they had to ensure that they met the requirements while running the supply chain for 30 days uninterrupted. And these challenges are indicated here, from expanding the number of stores to improving the overall supply chain. And you can see that some of these included very specifically to reduce the inventory cost, reduce facilities cost, reduce transportation cost, and then to put it all together. The survey developed was based on the recommendations of Durrani et al. 2015, and they have made some recommendations on how scenarios should be structured and the open-ended questions that can be asked. 6 scenarios were developed to evaluate 6 different systems thinking skills: dynamic thinking, cause-effect thinking, system as cause, holistic thinking, closed-loop thinking, and stock and flow thinking. The survey was administered by Qualtrics. It was completely voluntary, which was not a help at all because many students did not complete it. Students were surveyed before and after the simulation, and responses were then coded on a 5-point Likert scale based on recommendations of Arnold and Wade. So 1 equaled meant no development of the skill, and 5 very highly developed skills. And then the mean, median, and standard deviation was calculated for each question. So these are the results. The pre-simulation results indicate that dynamic thinking, cause and effect thinking, and stock and flow thinking had the overall higher means, but the spread of data was also wider, indicating that student proficiencies were also more variable. Whereas system of scores, holistic and closed loop thinking were lower with a much smaller spread of data. And then in the post-simulation, dynamic thinking and cause and effect thinking were also higher than the other 4. But in general, with the exception of one skill, all 5 were lower than in the pre-simulation responses. So here's a histogram that compares the difference. And you can see here, system of scores thinking is the only one that we see improving in the post results. So the aim of the study was to determine whether the skill level improved. So I did conduct a one-tailed paired student t-test with an alpha at 0.05, and I got a p-value of 0.1063, indicating that there was no improvement in the skill level. So in conclusion, the simulation did not seem to have an impact on the systems thinking skills of the students. All areas were weak and could benefit from development of the skills. I think it would be important to run the study again, but if it's repeated, there are several things that should be taken into consideration. For one, the response rate was very low for both of the surveys. Then other things specific to the tool should also be considered. For instance, answering scenario-based questions is considered to be very tedious, especially the later you go into the semester. Survey questions also need to be validated and tested for reliability. I use the structure recommended by Dorani and others, but that should also be tested and made sure that it's appropriate. The rubric should also be reviewed to make sure that the different options for coding the answers correspond with the questions asked. And the appropriateness of the simulation for the study should also be considered. The time span between the pre and post simulation studies is also important. I conducted this over a 3-week period, and students didn't seem to have completely forgotten what they had initially put in, so it wasn't really opportune when I did the second request. And then finally, I'd recommend that more than one person code the results so that there is a better reflection of the responses that are obtained. So this is my study, and I thank you for your attention.